Hello, everyone. My name's Gary, and today we're going to be going through the life of a commit. I work in Chrome Operations, which is a developer tools team responsible for building, testing, and releasing Chrome. Our motto is make Chrome easy to change, hard to break, and ship efficiently. So today we're going to talk about the first two things, which is making Chrome easy to change and hard to break. This is a very introductory talk. It's applicable to people at Google as well as external contributors because it uses all open tooling. All of the Git repos are out in the open, all of the tools are as well, and you can build Chromium on pretty much any platform that we support. There will be time for questions at the end. And so let's go over the process. So an overview of the process, it's actually very similar to the process for most open source projects. You start with finding a bug that you want to fix. You check out the code, you fix the bug, you upload the patch. We do use bespoke tooling for a bunch of this. So sites like CRBug, which is our bug tracker, Depot Tools, which is our way of kind of wrapping Git and doing some checkouts. Things like GN and Ninja, which we use for building, Gerrit, which we use for code review. A lot of this is open source, but it's also somewhat specific to Chromium in that this is a little bit different from your typical GitHub workflow. So once we actually get to testing, this is where things get pretty different because we run a ton of tests. We run probably more than a couple 100 million tests a day. Tests are run both before a change lands as well as afterwards. We test across all kinds of Chrome platforms, different kinds of tests. So race detection, GPU, basic performance, and then tests on all the platforms. So Mac, iOS, Android, Linux, Windows, all of that. Eventually, everything is reviewed. So it's very important to submit your change for review, where someone from the Chromium team will look at it and let you know what maybe needs to change or things to take into account. It's important to do this because this is a massive code base. There's a lot to know, and there are lots of like little corner cases or esoteric things that may work for you, but not necessarily for people running 2 versions back of iOS, for example. So the Chromium reviewers really have the knowledge to say, okay, you should watch out for this, and this is something to keep an eye out for. Lastly, you land the change, and then hopefully it isn't reverted, and you're good to go. So we're going to go through all of these steps today and go into a little bit more detail for each one of these. Okay, so first to get started, go to the chromium.org page. So here you see 2 projects. Chromium.org is home to both the Chromium browser as well as the OS. This is very much a browser talk. There are plenty of other sessions today for Chromium OS things. So we will talk mostly about Chromium today. There are also other sites for Chromium adjacent projects. So things like V8 or WebRTC have their own projects. Also, Blink is part of the Chromium project. So Blink is also within the Chromium code base itself. So we are going to click on the Chromium link, and that will get us going. So this is the generic landing page for Chromium. There's a bunch of different links on here, and this is a pretty useful one. It's getting involved, which tells you how to get started with the Chromium community and with the code base. So starting here, we clicked on that, and there are a couple different things that you can do here. First is joining the mailing groups so that you can get plugged into what the Chromium dev team is talking about, what's going on, what people are working on. There's also a Slack channel, actually, so chromium.slack.com. I don't think it's linked here, but it's definitely on the site as far as how to join it and how to participate in the discussion. There's also channels for asking questions. A good way to get started is actually getting involved with testing. So there's a couple different things that you can do. One is triaging bugs. So we need a lot of help in terms of taking a look at the bugs that are coming in, confirming them, making sure that they have good reproduction steps. So that's a big area where you can help. Also, verifying fixed bugs is a great way to both contribute as well as getting a good introduction into the code base, because by looking at the bugs themselves, you can see, okay, what was the initial problem? And then what was the fix? How did we actually get to the solution? And what did the code look like to actually fix that bug? But in this talk, we actually want to walk through making a change. So let's go with that. So with that, we actually keep a list of good first bugs for people to get started. The idea here is that these are bugs that are not too hard, and a good place for new developers to get started. So let's click on that link. So this goes to our bug database, which is at bugs.chromium.org. It runs on Monorail, which is a open source bug tracker built by us, somewhat similar to GitHub Issues or Bugzilla or Jira, if you're familiar with those. In there, there's about, on this list itself, there are about 1,000 open bugs. So these are bugs that have been marked as good first bugs. ID is a increasing number. So the higher number, the newer the bug, the lower the number, the older the bug. I think the oldest bugs on this list are maybe in the 3-digit range. I think there's like 600. So there are some pretty old bugs on here. You can also sort by stars. So that's also one of the columns. So you can see which bugs have received a lot of interest or which bugs people would really like to see fixed. I will say that some bugs are not necessarily good first bugs. I think over the years, we've gotten a lot better at deciding what is a good first bug versus what is not a good first bug. But some of the older ones can be kind of hairy. I think at one point, there was a bug on here that just said implement video capture, which was probably not a good first bug. So let's take a look at the first one on there and click on it. So this is a bug about updating some of our build tools to use Python 3. As some of you may know, Python 2 has been deprecated and everyone is moving to Python 3. Actually, it was deprecated at the beginning of this year, so we're a little bit behind on that. And this is an ongoing project that we're working on, which is updating all of our build tools from Python 2 to Python 3. So this bug talks about, here are some of the files to look at, what the goal of this is, and some areas to get started, as well as how to actually test the whatever changes need to be made as part of this bug. In there, you will see kind of on the second line, it gives you a file location to start. So let's look at that. So browsing the source code, source.chromium.org is a great place to start because while it's not exactly the Git repo, it's a search tool that allows you to search the entire Git repo. There's a couple of different projects indexed here. There's the Chromium project, the Chromium OS project, as well as GN, which is a meta build tool that we use to build Chromium, as well as a bunch of other projects. Now, if you start typing into that search box, it auto-completes the results, as you would expect. You can click on a folder or a file to go directly to the file or the folder, but you can also click enter and that will show you search results. And this is a great way to actually browse the code base. If you don't know exactly what you're looking for, just go with this and look through the different files. It gives you a search index that allows you to go kind of back and forth between looking at a file and coming back and so on and so forth. In this case, we see ui/ozones/build.gn, which is absolutely the file that you want to look at. Okay. So moving on, let's look through the file. In build.gn, there is Python 2 action. And this is something that a change that we made recently that marks the specific areas where we need to convert to Python 3. As you can see here, there's also the script, which says generate ozone platform list.py. This indicates that this is the file that we actually want to look at. Seems like a fairly reasonable bug. We've been able to trace through some of it through the code search. We can also look at the actual Python file itself, but this seems like a good place to get started. So When you start working on a bug, you definitely want to claim it. There are a lot of different people working on Chrome and on Chromium. And so, there's both internal as well as external, like internal to Google, as well as external people working. And so we definitely want to coordinate the work and make sure that we're not duplicating it. So to start, you want to mark the status as started and assign yourself as an owner. If you don't have bug editing privileges, there's actually a page on chromium.org called Get Bug Editing Privileges. Alternatively, you can also mail the mailing list and say, hey, I want to start working on this bug. But also, if you're an external and you just want to get started and you're not sure if this is the right bug that you want to get started with, just start working on it. And once you've made a decent amount of progress, let people know, and we can get the bug assigned to you. So next, we want to get the code itself. So thankfully, on the chromium.org page, there is another link to actually getting the code. So this is getting the code, checking it out, building it, as well as some information about things like running tests. So let's click on that link. So these are instructions on how to build Chromium on different platforms. So Linux, Windows, Mac. There's also a couple, there's a little more around iOS and Android. This is building Chrome for those platforms, not necessarily building Chrome on those platforms, but building Chrome for those platforms. If you work at Google, there are slightly different instructions linked at the top. There are Google specific instructions, and you should use those. Okay, so first step is getting something called Depot Tools. Yeah. Okay. So first step is getting something called Depot Tools. Depot Tools is a repository of tools for working with the source code. It basically wraps Git. Well, there's a bunch of tools in here, but one of them wraps Git. It clones pretty quickly. So as you can see here, I cloned the repository and it finishes in about 5 seconds. This was done on a really fast machine, or a machine with a large amount of bandwidth. So, but usually it will clone pretty quickly. You want to add Depot Tools to your path, and now you can check out the Chromium code itself. So next step is using fetch to check out check out the actual project itself. So fetch Chromium. This fetch is the tool that I was mentioning before that actually wraps Git. It actually wraps gclient, which then wraps Git. Gclient does both a Git checkout as well as syncing dependencies. So you can kind of think of that like Git submodules. The Chromium repository depends on a bunch of other projects, and it also pulls those down because they're needed for the build. So we call fetch Chromium, and this may take a while. Chromium is a very, very large project. The checkout is probably about 30 to 60 gigabytes, depending on the platform. And it can easily take over an hour on a fast connection or overnight on a slow one. So we're very sorry, but there are a lot of things here, and there are a lot of there's a lot of different bits of code. So now you have the code. In this particular instance, it took about 35 minutes and used 40 gigabytes of disk space. You can actually use a parameter called -- no history. I think the docs mentioned this. And that will speed things up drastically because it doesn't pull down the full history. It just pulls down basically the most recent version of each file. I ran it as well, and that took about 7 minutes versus the 35 minutes that you see here, and it was about 15 gigabytes in terms of the checkout itself. So next is making your changes. I'm going to gloss over the actual changes that we need to make because Chromium is a big code base, and there are a lot of different things that you can do. There are a lot of different areas that you can work on, as well as like changes to different languages and code bases and all of that. I will mention a couple of tools. So For building Chrome itself, we use a tool called Ninja. It's an open source tool. It's similar to Make, but like very bare bones, and it does really fast compiles. GN is a meta build tool, so it's a little bit more like CMake, and it stands for Generate Ninja. And it basically generates Ninja files for Ninja to actually execute the compile. Make sure that you run and build you build and run the Chromium browser. You can play with it locally and just see what different changes do. And then there's also instructions on how to run tests. All of this is in the checkout and building Chrome link on chromium.org. This particular change actually doesn't involve any of that, or at least it doesn't involve mucking around with C++ files. It is actually, what we actually have to do is modify Python code. So let's go with that. So next step is after I've actually made the changes, you can see that I have two modified files here, generate constructor list and generate ozone platform list. You saw those referred to a little bit in build.gn. After this is a fairly standard workflow. So git add, and then git commit with your commit message. One of the things that you really want to do is link the bug to this particular commit, which will eventually turn into a review. So we do that with git footers. You see a bug colon, and then the actual bug number. After you've made that commit, you want to run git cl upload, which is a bit of a git extension that we have that you fetched from Depot Tools. And that will upload your change for code review. First, it will run some local sanity tests to make sure that your change is good to go. And then it will pull up an editor to allow you to write a description for your change list. So pre-populates it with your initial commit message, but you can also add a bit more information about what this change is all about. Once you save and once you save and quit, your changes will be uploaded to the code review site. So this is after that command is run. You can see that it calculated the patch set and then uploaded that. In there is actually a URL. So copy and paste the link to your browser. That is actually the link to your review. So this is a tool called Gerrit, which is our code review tool. It's an open source project developed by Google. There are a bunch of different projects that use this. It's similar to GitHub pull requests with a couple of differences. For one, you upload patch sets, not branches. So you upload basically diffs at a time. Every merge is a squash and merge, which means that you're never like merging branches or anything. It's just all of your commits are squashed into one commit and then put in at the top of tree. The CC list is automatically populated. So so it notifies the right people about this change. And as you can see, the work here is labeled as work in progress. So nobody has been notified yet as far as the actual change itself. But you should scroll down and you should look through your changes. So if you scroll down, you'll see a file list. And then if you click into those files, you can actually see the individual diffs. So that's a fairly standard view. And there's a button at the top, if you go back, called CQ Dry Run. So this actually kicks off our automated testing, which we touched upon a little bit at the beginning. You should definitely do this before you send out a change for review. What it does is it applies your change to the tip of tree on Chrome. So not just like where your code was when you uploaded it, but what your code would look like if it applied that patch set to whatever is currently on in the Chromium Git repo. It runs a bunch of different tests on different platforms and machine configurations, and it does exactly what would be done if you tried to submit this change into the commit queue, which is why we call it CQ Dry Run. Once you click on the button, you want to scroll down, and this is the try jobs section. So down here are all the different tests that we run for a commit before it gets submitted. We call it a try job because what it does is it actually tries a change. And each box here is a different, I guess you could call it a set of tests. It's basically a build, and in some case, a large number of tests. So, and they each test a different thing. So as you can see here, some of these are Android tests, so Android Lollipop and Marshmallow. There is also Chrome OS test, Fuchsia tests, your kind of as you expected, like the main platforms, Linux, Mac, iOS, Android, Windows, all of these are tests. And then there are also some architecture tests like x86 versus ARM, and some correctness tests. So TSAN, which is a race condition tester, and ASAN, which is a memory tester. And here are the results of the dry run. So you can see that this particular change actually failed on a bunch of different platforms. Green means that it completed successfully, red means that it failed, and yellow means that it's still testing and it's still working through. So let's click into one of the failed builds. So if I click into Linux RHEL, this is the box that shows up right at the top, and it will usually give you a good synopsis of what broke. In this case, the error here indicates that the changes that I made were not Python 2 compatible. Generally, this box will surface whatever the error was. It's not always the case. Sometimes there are some really esoteric errors, and you'll need to scroll down this page where you can see all the different steps that happened, like compile and running tests, and you'll need to dig into like log files to actually fish out exactly what the problem was. But most of the time, there will be a good synopsis right at the very top. So I go back, I make some code changes, and I re-upload the patch set. So I modified some files here, mostly to make these scripts also backwards compatible with Python 2. And I commit these and then re-upload it. In this case, I'm actually using a amend commit, which updates my previous commit. This doesn't actually matter too much. Git-cl upload, what it does is it creates a diff and uploads that to Gerrit, and it does it based on whatever branch you're on. So if you have, doesn't matter if you have 10 commits or if you only have one commit, it'll collapse all of those and upload them to Gerrit. So I run git-cl upload, and I go back to the review. So here, once I've actually uploaded, this unfortunately is not quite an updated screenshot. I forgot to capture a screenshot of what happens once you've uploaded the patch set, because usually there would be a button here which says something like retry failed jobs from patch set 1, which you can click on to rerun the ones that you failed. In this case, I actually clicked dry run, which is all the way at the top, to just run everything one more time. And more time passes. This will usually take around 45 minutes. It was very quick the first time because it failed early, but for a successful run, it can take anywhere from 20 on the lower side to upwards of 45 minutes. There's a lot that's going on here. It's running somewhat over 2 days worth of tests across all the different platforms and all the different architectures. So this is what happens at the end, hopefully. So all of it is green, everything, all of these individual try jobs passed. So let's get our code reviewed. Okay, so scroll back up to the top. There's a button there called reply, which actually kicks off the formal code review process. You want to put your reviewers on there. You definitely want to include the person who filed the bug, as well as maybe look around for people who may have touched this code before, and people that you can include for your code review. It's usually not instantaneous. Reviewers are going to be doing other things, working on their own projects. Sometimes they're in a different time zone. So it's probably good to work on several changes at once. And so when this change is ready, dispatch it and then come back later. I'll talk a little bit about the labels, which is that section kind of towards the bottom, which says auto submit, code review, and commit queue. So code review is how we indicate that something has been approved in the review itself. So +1 is approval, -1 means, hey, there's something wrong with this and it's not ready to be merged. The commit queue +1 is actually the CQ dry run that you saw me do earlier. So CQ dry run is the same thing as CQ +1. And then CQ +2 is actually doing the merge. If I actually tried to do a CQ +2 now, it would fail and tell me that nobody's reviewed it or nobody's. Just have a side note, if you're a reviewer, we ask you to be fairly responsive, so less than 24-hour turnaround. There are guidelines on the site about how to be a good reviewer, and if you're too busy to look at it now, please find someone else, or at the very least, notify the author that you're too busy and when you're going to be able to look at it. It's really frustrating if you upload a patch set and nobody looks at it, or nobody responds to you, and we really try to avoid that. So in this case, I came back the next morning, and it was approved. So then there's the button at the top, which is submit to CQ. So this, as I mentioned, is the same thing as CQ +2, and it starts the commit process. So yet more time passes. This runs everything that was run in CQ dry run. If you did CQ dry run recently, it can actually reuse the results if there's been no additional code that was changed, and the results were relatively recent. In this case, it had to rerun everything. Again, it applies your patch to the tip of tree, not just to where your original branch point was, which means that there may actually be merge conflicts. So there's a chance that you will have to rebase your changes, in which case, go back to your command line, rebase, resolve your conflicts, and upload another patch set. So hopefully, if everything goes smoothly, your change lands. You'll get an email telling you that happened. Also, that little label at the top goes to merged. In this case, it took about an hour. And you can see a link next to that. So it says merged as, and then a hash. That is actually the link to the commit in the Chromium codebase. So if we click on that, that actually brings you to the Git repository. And this is the commit that I landed. Congratulations, that is your first change. Except there are way more tests run after this. So why are there more tests? Well, some tests are way too expensive or take too long to run. So for example, we run tests against all 5 previous versions of macOS, so 10.10 to 10.15. That would be a tough thing to run against every single version, against every single change that people are trying to apply. So those are tests that we run after the actual commit. There's also like fuzzing tests, performance tests. Some tests require specialized devices. So recently Mac are moving the architecture to ARM, and there's a limited number of those devices. So that's another example of tests that we only run once changes are actually committed. And so we have a whole set of other builders that are constantly testing the tip of tree of Chromium. So they're constantly checking out the most recent version of Chromium and running whatever tests that they're responsible for. So let's go take a look at those. So we go to build.chromium.org, and that shows not all, but the major continuous builders that we're constantly running. Each of these boxes is a builder, and there's a section up there called tree closers. So tree closers are builders that have the ability to block changes from getting merged in. So basically, if something gets in and, for example, it's breaking compile, one of those builders will fail, it'll close the tree, and then it allows people some time to try to fix the problem without like more commits getting piled in on top of that. If we scroll down, you can actually see my change right there. So these are, similar to the boxes above, these are all the different builders. You can see this is actually quite wide. There's a long scroll bar at the bottom. And each column is a different builder testing a different thing. If you look really closely, you can see the 10 to 15 in the Mac section, which is those Mac builders that I was talking about before. 99% of the time, these builders will yield exactly the same results, which is why it would be a waste of time to run these for every commit. In post-submit, which is what we call this, these builders actually test batches of changes at a time. So they'll bundle together, based on how quickly they run, they'll bundle together a batch of changes and then test them all at once. So my change right there has actually been picked up by 2 builders right now. And over time, every single builder in this list will cycle through and test that change. Most of these tests work within about an hour or so, but some may take up to a day, some of the longer ones. So we have a team of people called sheriffs that watch these builders. They are really responsible for hunting down the root cause of failure. So if they see a builder breaking, they will investigate and try to figure out which change actually was the problem. So these sheriffs may revert your commit. It's definitely possible that you make a change and it turns out that it breaks it breaks in for performance or for some other reason, and the sheriffs will go in and say, hey, we think this is the change and let's revert it. Because most tests run within an hour, because tests run within a day, beyond a day, you can pretty much call your change safe. Reverting a change happens rarely, but it definitely does happen. So just keep in mind that once it's merged, it could still get reverted. And then the last step is, assuming that the change sticks, go and mark your bug fixed. So there is a process in the background that takes this change and puts it into the bug itself. So you'll see it in the bug history. Mark the status as fixed, and you are done. So hopefully that gives you a pretty good overview of what it's like to land a Chromium change. Let's go with questions. Dirk, my co-presenter, is going to be answering any questions that you might have.
Let's see, hi everybody, are there any questions? Maybe not. Looks like the answer is no, there aren't any questions. So, good presentation, and thanks everyone. And if you do have questions in the future, please reach out to contact us on the mailing lists or any of the other resources that Gary mentioned earlier.
All right, thanks everyone. Oh, Can we have a link of the slides?
Yes, I believe
Yeah,
those will
I
be
think so.
made public as part of the presentations.